Okay, hello everyone. Welcome to Dispatch, IETF 111, the start of IETF 111. This meeting is actually also my 10th IETF meeting, so I feel like I deserve a cake or something. Hopefully you can all see the slide deck in front of you. You can all hear me okay. It's great to have us all together for another virtual IETF meeting. You're here in Dispatch. Hopefully you're expecting to be in Dispatch, which is combined with the art area meeting. And it's myself and Patrick McManus who are co-chairing Dispatch today. Yeah, thank you everyone putting cake in the chat. That does actually make me feel quite good. So welcome whatever time of day it is for you. We're just going to run through a few instructions. This is the first session of every IETF week, so you may not be as familiar with the technology or kind of the protocols, no pun intended, that you need during the week. So we'll just go through them now. So first up is the Note Well. You'll have all agreed to this when you signed up to register and participate in the IETF meeting. It's the definition of code of conduct. So as a reminder, by participating in the IETF, you agree to follow IETF processes and policies. If you're aware, any IETF contribution is covered by patents or patent applications, let us know. And everything is done in accordance with all of those BCPs as well. Okay, so this session is being recorded. Participation tips, please use headset if you can. Add yourself to the Meet Echo queue to speak. You just do +Q, so write a +Q, or you can raise your hand. If you look at the top left of your Meet Echo chat, there's a join queue, which looks like a hand with a slash through it. Please say your name before speaking, so that will just be Kirsty P or Kirsty Payne, NCSC for me, so that we can keep an account of who is discussing and who is bringing points to the queue. Do use Jabber, that's just on the side of the session for you, and you don't have to worry about blue sheets. That's taken from the Meet Echo roster. So there are some useful links there uploaded on the meeting materials as well in Dispatch. So yeah, welcome to the IETF 111 Dispatch virtual meeting. It's the 26th of July in some time zones. Welcome, and here's our agenda for today. We're going to spend the first 5 minutes just taking a check of where we are and doing an agenda bash. And then we have a few topics in Dispatch today. JWS clear text JSON signature options. Then we've got 10 minutes on image WebP MIME type registration. Then 20 minutes on NICER, which is a usage profile of ICE. SDB coming up for 10 minutes afterwards is not recommended and historic. And then another 10 minutes on the large file in email problem. And then we have, after that, the art part of the meeting. So we've got a list of the BOFs, interesting updates and other meetings of interest. Then we've got an update on a new code spec from the Stellar working group, IPv6 zone identifiers and URIs, and reliable, unreliable streaming protocol, RUSH. So if you are interested in all of these talks, that's the agenda we're sticking to today. All of the slides and meeting materials are uploaded on the IETF pages as well under the Dispatch session. Okay, and as a reminder, there are mailing lists. For general discussion of art topics, please take it to the art mailing list, art@ietf.org. And to discuss work proposals that need to be dispatched, go to dispatch@ietf.org. And I'll just pause in case there are any comments or changes to the agenda. But hearing nothing, we'll start with our dispatch topics. So first up, we've got Samuel Erdmann presenting on JWS clear text JSON signature option. Do you take the floor?
Thank you. I hope everyone can hear me. Do I click the slides or do I ask you to do it, Kirsty? I'll just try to do it. So JWS JSON web signature clear text JSON signature option. I will go into the rationale and then just a rough overview how it's meant to work. And then we can go into questions and comments. And next slide, if I'm not the one doing that. Yeah, so This is more or less copied from the document, but if you haven't read it, so JVS clear text JSON signature option describes a method for extending JSON web signature standard called JVS CT by combining the detached mode of JVS with JSON canonicalization schema, maintaining signed JSON data in JSON format as it's being transmitted or stored or whatever. Next slide. So there is a set of reasons when one might not want to only use the JVS as is, and just to list them here and go into slightly more detail. So in situation where you have predefined JSON structures that you want to use, and you want to maintain backwards compatibility as you add signatures, it does not work to repackage the whole thing into a JVS, but you have to instead add a signature on the side in some way. So this document describes how to do that and add it into the JSON structure. You might have large data structures in JSON format that are shared between organizations, and you signatures added in later steps. You might augment the JSON as you go along and sign it as you go along. Then it's also very inconvenient to put it within the JVS signature. So there it's very convenient to have the option to create the signature and add it into the JSON document afterwards. Adding multiple signatures and nesting data structures, it's a bit of the same as the previous one, but more general. When you do this, it becomes like a parsing nightmare when you put them inside each other again and again, even though it's technically usually often doable. And then if you need or want to transmit unsigned data, it's convenient to just not add the signature, instead of package it in a JVS and then have the non-algorithm being used. Maintaining JSON data, JSON data while in transport makes readability and debuggability easier also. These are some of the reasons that has come up when discussing this work. Next slide. And yes, so constructs. So next slide again. So as it's specified today, the canonicalization to get something that's signable uses JCS RFC 8785, which takes JSON and puts it in a canonical JSON format. It's 100% JSON valid, but it limits the expressibility of JSON slightly by limiting it to iJSON. Then there is always the number discussions and so on, but it works super nicely in practice as we've tested it a lot. But there has been conversations about this on the dispatch mailing list, just to make that clear. Next slide. The other constructs that used for this is the JVS detached signature. So at the top you can see a normal or classic JVS signature. I don't know if it has a specific name, where you have the data embedded here in the middle as purple within the signature. But if you do a detached signature, just leave out the data part from the signature. So you have the header, the red part, and then the blue, which is the signature bytes. Next slide. So here we go into how this works out in practice and the different steps for doing this. So when signing, so let's take next slide. So first is to create the JSON object to be signed. So like, yeah, the normal application process. And you can see the example here by the side. Not very advanced in this example. Then we go to next slide. where you prepare the JSON to be signed by canonicalizing it, so it becomes slightly shorter, removing white spaces and so on, but that's another specification. Then next step, next slide. Then you can use the, like, whatever JVS library implementation you use, and use the canonicalized bytes as input for the signature, but you then remove it as described in the appendix of the detached signature. And then this is what you get. And next slide, and then you assemble it together. You put in your signature into your JSON that you will then transmit or store or whatever you want to use it. This one, the signature is shortened here. So that's the signature process. We don't dictate that it would be called signature or at what level to put it, but, or we say root level, but don't dictate the naming because that's very application specific in our opinion. Next. Then we go into a verification process. So you receive or read this from somewhere, a JSON blob, you parse it, getting all the attributes and everything, and then we take the next slide. Next slide, please. Thank you. You extract out the signature attribute, the signature property. Yeah, detached, nothing strange. You go to the next slide. Remove the signature property because it wasn't there when you canonicalized and signed it, so you need to remove it. And then we go to the next slide. And here it's again canonicalized. And then you do the last step, next slide, where you have taken the canonicalized bytes and put it into a JVS signature, then do the validation step according to the JVS. So here you see the data part to make it possible to use like any JVS library. So this makes it like super compatible and super easy to implement with existing libraries. You could add a last step here where you took the canonical object, since it's JSON and parsable, and then you parse it again to make sure that you actually operate on what was canonicalized and signed in practice. Next slide. So yes, I mentioned before, the document does not dictate signature attribute or property name or location. It is up to the application to choose a suitable name and location for the signature attribute in its context. The document does not define counter signatures, arrays of signatures, or detached signatures, but it exemplifies how it could be done in appendices. Next. So this work has been up on the in different forms on different mailing lists. We suggest that we move forward as ISE since the canonicalization RFC 8785 is published as an independent submission, and since the Jose working group, where it could suit, if I understand things correctly, that working group is closed, but it has also, which might be more important, been very limited interest expressed by the people from that list, even though we see interest from other groups. Next slide. However, if you're interested, we would love to get reviews and comments and suggestions to make this work even better. Next slide. And yeah, thank you for listening. It's time for questions and comments. I've seen Karsten here, but I just wanted to mention that he sent an if. He does not have time to speak for himself during this meeting. He sent an email being explicit that he does not like the clear text name. I don't want to hide that in any way. To me, clear text makes sense because that's how it's perceived, but I get that it might not be the technically most correct name. So I'm not sure exactly how this works. My presentation is done, but
that's okay. Thank you for your presentation. So now we look at the queue. We've got a few people in the queue. Really interested to hear your thoughts on the dispatch question, where this should go, and of course any clarifying questions that you have for Samuel. So if you want to manage the queue yourself, Samuel, it's Carsten first. And just a reminder, please state your name before making a comment or question. Thanks.
Yeah, Carsten Burman, thank you. I said I cannot be at SEC dispatch because IoT Ops is on top of that, but I can be here. But I really wrote up everything I need to say in that email. So just please read that email. The name of the thing may seem like bike shed material to you, but in reality, it's what will shape the market reception of that. And as other people have pointed out, and of course, everybody who was here 15 years ago knows, there are some issues with the general architecture behind that. And it's pretty clear that the marketing material that presents this as just a clear text way to do signatures is misleading people about the complexity of the issues that they're going to incur. And that's why I believe the naming of the thing is very important. And whether we want to work on that or we want to send it to the ISE again, I don't have a strong opinion on. I hope others have.
Thank you, Carsten. I think so. I would not personally be against changing the name if we can come up with something more suitable. I guess I would propose here to maybe, if other have suggestions, but I'll take like the naming discussion on the mailing list, for example. So that's something that could be very well done in synchronously.
Hey, hi, this is Sean Turner. I guess I'll jump in. I think I'm the next person in the queue.
Okay, sure. Run.
I have a clarifying question. Do you think that this RFC will end up being referenced by other working groups? Because if you go to the ISC, you're going to be stuck at most informational. So if you think that this is going to become like a standard normative reference, you're going to have to uplift it anyways. So that would kind of dictate that you'd want to be not through the ISC, you'd want to be through an AD or a working group. So I guess I'm just kind of curious, the ultimate plan for this, is this kind of like nice to have, or do you think there's going to be lots of working groups that are going to try to adopt this? Thanks.
I think, so there has been discussions on different lists. We've tried to propose it at least once before as a extension to the HOSEA working group. Based on the reception, I would maybe not actually expect many other working groups to adopt this, but rather actually my perception is that it's more of a in the wild de facto thing. People want to do something like this. They want a document where it's defined so that they can implement it and get some interoperability. I would love to see if it to me it seems useful. So therefore it would make sense for other working groups to use the constructs, but I'm not at the current state super hopeful about that. Thank you.
So I sent some comments via email. Roughly speaking, I'm not like really persuaded this is a good idea, but I guess if you take it to ISE, it can sit with many other bad ideas that have also been published by the ISE. So I think that's the appropriate place to do it. I sent you some technical comments, which you, under the circumstances, can ignore or not ignore.
Thank you. Please. tell us? Or you sent, it wasn't
I sent them an email. I think probably the most relevant one is, like, I think having the canonicalization as part of the signature process is quite unwise. It'd be much better to phrase this as the channel for which these are transmitted needs to be transparent to the JSON, and then and then people can accomplish that by canonicalizing on either end or not, as they please. But having this be part of the signature process is like how we got to, like, the messes we had in previous canonicalization efforts.
Okay, just want to make sure I understand you correctly. Are you saying that the canonicalization process should be out of scope for this document? And
so I agree. So I agree. You have to have. So what I'm saying is that the technical requirement for signatures is the input of the signature and the output of the signature has to be the same. And you propose to accomplish that by adding a canonicalization phase prior to the signature and verification. And what I'm saying instead is that you should make this an application problem, as the application is responsible for delivering data in an unmodified format. And it can do that in a number of ways, one of which is actually having a transparent channel, and one of which is canonicalizing on either end, right? And and then we don't, and then we're not, like, building, and then for instance, that doesn't require you for any specific canonicalization format at all, because this application's problem, not this system's problem. So yeah, that's what I would do. But in any case, as I say, if you take it to the ISE, you're free to ignore me. I mean, you're always free to ignore me, but it'd be especially free to ignore me in that case.
No, but it's an appreciated comment. I guess it's it depends on what you want to hand off to the application implementation, what you believe is valuable to specify and define and and so on. But it's definitely a valid comment. I guess if we look at the classic JBS, they do that by, they define the canonicalization as an ASCII armoring solution instead, and here we define it as JSON canonicalization. And the ASCII armoring is, maybe more proven, I would say. But okay. Should we take the next comment?
Yeah, so this is Patrick. Before we jump to Cullen, who's next in the queue, we didn't maybe cover the sort of dispatch process. And hey, we have Cullen as the working group chair emeritus here who can let us in on it. But just to remind folks, the primary goal here of the dispatch section of our agenda is to consider whether we want to find a home for these work items within the IETF, and if we do, where we think that might best be formed, be that a new working group, an existing working group. Perhaps we don't want the IETF to adopt it at all. The chat has mentioned the ISE. Just the ISE isn't really in our purview, so certainly things that we recommend we don't adopt may want to pursue that path independently of what we do. And a reminder that really this is just an opportunity for the collective wisdom of helping things find a home in the IETF really be brought to bear. The final decisions, even though we sometimes talk about dispatch consensus, the final decisions really belong with the ADs. So with that, we're still talking about this particular draft. Cullen, what do you think?
Man, I'm the best chair of this group ever. I was just going to basically point out that problem. All I was going to say is, when we say send this to the ISE, what we mean from a dispatch decision point of view is the IETF should not take this on, which is a perfectly valid way to dispatch things. But I think that we should be clear that that's what we're saying when we say that, because just sending something to the ISE is not a decision this group can make. We're just saying that we wouldn't do it in the IETF. So thank you. That was everything I wanted to say, Patrick.
Hi there. So Ecker's explanation of what should happen with this was actually quite helpful to me. I think that the idea of having a signature that doesn't require ASCII armoring is interesting for a variety of things, not just JSON. But I agree with Ecker that this approach of trying to come up with a canonicalization is going to cause great pain and suffering and shouldn't be done in the IETF. If you want to do it in the IETF, and I think Sean's reasoning behind that this might be adopted by others is a good, a good point. I think taking on what Ecker was saying and actually thinking about how to make this an application layer problem might be a good idea. It might solve problems for other folks along the way. That might be more work than you're interested in doing, but I think it's at least something that you should consider.
Thank you, Pete. So we're just coming to the end of the slot here. So I'm going to start a show of hands. So for those of you, this is the first session. So if you're not familiar with the tool, we're asking, should the IETF take this on? So if you think the IETF should take this work on in some way, then you raise hand. If you think that is not an option, then do not raise hand should be what you select. And that could
Can you hear me? I can't hear Kirsty either. Okay, you can hear me. So Kirsty set up a poll over in the raise hand section here, where we're going to draw a poll here. Kirsty had the language figured out, and I just got to wing it. Kirsty set up a poll about whether or not we want to, should the IETF take on this work, just positively or negatively, with the implication being that we would recommend no working group action be taken should we not want to take this on. Kirsty, can you open it up? Can you talk, Kirsty? Pete says it sounds like Kirsty came back.
To tap the little bar graph thing in the row of icons at the top, but it's actually active and being voted on.
Kirsty is offline as well, so I think she's trying to reconnect.
All right, I'm going to end this session in just a couple more seconds. There haven't been many participants at this point. And what we'll do is Kirsty and I will chat separately during future presentations and come back and sort of give a summary of what the room thought later in the meeting. All right, going once, going twice. Thank you all for that. With that being said, we will move on to the next presentation. Kirsty, can you hear me and still control the slides? Apparently you can.
Yeah, I'm back now. Sorry, everyone. Yeah, so thank you very much, Samuel, for bringing your work here. Yes, and we'll move on to our next presenter. So it's James Zern. I'm presenting on WebP media type registration. Hi, James.
Hi, thanks, Kirsty, and thanks for the help in setting all this up and running the slides. So just for some quick background, I'd like to introduce the WebP image format, the motivation, and then move on to talking about where this best fits in working groups. So next slide, please. For people not aware with the format, it started off as a lossy compression, replacing or looking to fit the JPEG use case, and we kind of iterated on it through this time period, adding lossless, alpha, and transparency, and then animation. So roughly the format was finished and finalized, hasn't had modifications since about 2013. I will say that during this time, image/WebP was used, which made it a bit nebulous what that meant. Fortunately, we were controlling some of the integration at that point, so it wasn't a huge issue. And then maybe next slide. And for general availability, we're in all major browsers, and these are all have been using this MIME type since they added support, as well as a set of image viewing, editing applications, and things of that nature. So really, the goal of the format is to replace use cases for JPEG, PNG, and GIF for animation. And that's really the very brief background on the history here. And maybe the next slide, I'd like to open it up to discussion about where this best fits, so that we can get this registered, because I think it's blocking a little bit of other standards work based on our bug tracker for the project. So I'd like to get this registered and allow them to move forward.
Okay, thank you, James. You can see people joining the queue. Just as a reminder, to join the queue, click that hand with the line through it. And Barry Lever, you're up first.
Hi, this is Barry Lever. It seems to me there's no reason this should even go into an RFC. This can just be requested using the expert review path. And that's what I think. That's what I think you should do. Write up the specification, post it somewhere, and submit it to IANA.
Barry, you cut out a little for me in the first half of that. Maybe you would repeat.
Yeah.
Okay. You probably got. I don't know. Maybe you got most of it. I will put the microphone closer. This should just be written up and posted somewhere, and then submitted to IANA as a expert review request. There's no reason to do an RFC for this.
Right, and I guess I should have led in with that. Thank you for the comments. I had originally started with the IANA, and they actually requested that I go this path, filing a registration RFC. To give it a place to gather all this information. So did
the IANA staff request that, or did the expert reviewers request that?
When I submitted, I believe one of the chairs suggested that I go with the IETF path, or the RFC path.
Okay, I'm puzzled, but okay.
I can pull up the mail and maybe add that detail to
yeah, let's take this offline, but,
to the mailing list. But yes, I had started there, and actually at the same time, there's Murray. Murray probably has a better description, and thank you, Murray, for the help in bringing this together.
Murray is one of the expert reviewers, so he could answer that. Yeah.
I suggest. Let me try to find the email. It's in a different tab here. I remember suggesting that was an option. Under the idea that this working group its charter allows it to do simple administrative documents. If dispatch agrees that that's all this is, it could be processed this way. Otherwise, we could do back through the media type reviewers, as Barry is suggesting.
Yeah, we usually use dispatch for that when we have a need for an IETF consensus document. For media types, we don't. The process allows expert review, and there's really no reason to have an IETF consensus document and to go through all the overhead.
I think that's fine with me too.
Murray, would you be willing to sponsor this as an AD?
If it's necessary to do so, I think I agree with Barry at this point that we should just see if it can go through the regular media type registry. Oh, but this is asking for a standards registration, right? The standards tree.
Yeah, you can register in the standards tree with expert review.
Okay, let me follow up on this rather than taking up the working group's time. I'm fine with either of those two. This is relatively lightweight. I think that I can dust myself off from the last one and sponsor it if I have to. But otherwise, let's try it the expert review way first.
Okay, thank you.
Hi,
Tim?
Yeah, hi. I assume there is a spec for WebP written somewhere that would suffice for a competent implementer to code it up and get it to work.
There are, and I think that was probably part of the some of the concerns in the INA, since it's a combination of different compression algorithms. We have resources for both, but we don't have a blessed official specification, if you want. I would argue that the information is there, and we're it's within this this draft actually. So I think the details are there for an implementation to happen. Yes.
Yeah, I mean, that seems like the core thing to me. I don't favor registering a media type unless there's a document that a competent implementer can go look at and write code so it'll work on whatever their box they're running. If such a thing exists, then I'd be dubious about the wisdom of investing the time and turning it into RFC format if it's already perfectly good. If it doesn't exist, I was a little worried at what you said, to be honest there. Well, it's kind of here and there, and you know, that sounds a little worrying.
I would say it's 3 documents is what it is. There's not an all-in-one spec, if you want, for like what you would see in a video specification, like we might have for AV1 or 264, things of that nature. It is, we have a container reference, and then we have, as part of it, the lossy compression is VP8 format. We have a specification for that, and we also have a specification for the lossless component of the format. So really the effect of the draft is that it gathered those bits of information together, though they are gathered on our hosting site as well.
Okay, we're just going to cut the queue there. So Colin, in the interest of time, make it quick, please. Cullen, we can't hear you, but we can see you. So you may need to just change your audio.
I've clicked the 5 buttons the 5 times. Can you hear me now? Okay. Can anyone hear me?
Yes, yeah, we can hear you now.
Okay, thank you. So I think it's not so much the specifications for the bits inside, the compressed and uncompressed bits, but the definition of like any tags or other attributes that go along this. Last time I looked, I couldn't find those very well defined anywhere. And it seems that having those well defined in some document somewhere would be really useful, whether it was just an informational draft, but something that was a stable reference that we could refer, that IANA could refer to in the registration. So I think we should find some way to help make that happen. I don't care if it's inside IETF or outside, but I think that would be useful for this type of media registration that's going to be used so widely.
Thank you.
Thank you for the feedback. We have some of the format documentation. I think that's covering what you're suggesting. So I think we have the path forward there.
I agree. The format is well enough defined that someone could implement it. It's not stable references, but it's well enough defined. Okay. But the part with the other parts that go along with this registration, I'm not sure that you do have them all defined anywhere, or at least I can't find. So that'd be well worth making very clear.
Okay. Yeah, and if you want to follow up on the email, then the list, I can take a look into specifically what you're asking.
Sure.
Okay. Thank you. Thanks very much, James, for bringing your work to Dispatch. We'll roll on to our next presentation now. This is nicer ice based on RT2. So Harold.
Hello. Been a while. And just nicer was a very nice acronym. And it's actually not based on RTT, just so it's also wrong, which is kind of traditional for acronyms. So it's all about getting connections running, getting the right connection to send packets at the right time, so that stuff after we've started sending packets, it continues. So next slide, please. So the canonical description from Jonas is about when he comes walking back to his house while talking on the phone on, of course, WebRTC call. So he walks up to his house. It starts getting just a bare connection to the Wi-Fi in the house, and brings up the interface, gets the address, and the address gets trickled to his connection, and it says, "Oh, that's a Wi-Fi. It must be cheaper than 4G, so I'll switch over." So he walks a bit closer, and it actually becomes strong enough to be usable. And then the path curves around the corner of the house. There's a tree in the way, and suddenly he loses a signal again. And then he walks into the house, and he would really like to have continued the conversation throughout these steps. He may or may not have lost the actual interface while he was behind the tree. Probably he'll keep it because it takes a while to lose a Wi-Fi interface on the phone. But you see, this was not what ICE was originally designed for. Next slide. So the way ICE works, you basically set up a connection, find all the possible paths that could connect the two, try them in some order until you find something that works, throw away all the other information, and continue to use that until you do a nice restart. The basic idea of Nicer is that rather than throwing away all these other paths, you keep them around, at least if you suspect that they might come in handy and aren't just aliases for the same path. In order to keep them around, you got to keep probing them. Ping, 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 ping. Because a path that isn't working anymore isn't terribly good. And when one path deteriorates in quality so that you suspect that another path is better, you switch. And if the bad path turns good again, you switch back. So that in theory, you should be able to continue talking without a nice restart, as long as you have at least one good path. And this actually measures pretty well with Chick-Lice, where you have new candidates and candidate pair sets available whenever the new interface turns up. Of course, there are lots of details. The proof of the pudding is in the eating, as they say. And there are lots of tricks and tunings and performance optimization we can make. I'll mention a few of them over the next few slides. But for this purpose, as an IETF standard process, I'll focus on the changes that we need in order to be interoperable. Next slide. So the most important thing is to say that the ICE controller can change the selected ICE candidate pair at any time. And that we have to be explicit that when you have ICE candidate pairs which have successfully established connectivity, you don't throw them away. You keep them around until they don't connect anymore. And of course, support Chick-Lice. What we think, based on experience, is that if we have these three things standard, we think that any nicer controller endpoint should be interoperable with any control the endpoint. And the actual tricks and treats and optimizations can be left as a matter of local implementation. We don't have to standardize those. Next slide. So in the experiments we did with NICER, there are a number of changes we could do in order to make it perform better. I mean, just the size of the ping packets. ICE uses a quite large checksum. So if we just did CSE 32 instead of CSE 128, that's a few bytes. And some parameters of pings are unchanged after the first ping. We don't have to send them again. We know that it's the same connection. We also have the option of telling one side telling the other more about the network conditions, which interface exist and so on their side, so that the ICE controller can make ICE control decisions based on information about the other side. So that's some privacy concerns. I mean, people in the W3C tend to be very nervous about fingerprinting, and with good reason. So we have that it is a bit back and forth. So next slide. So the two important decisions that ICE controller has to make is when to ping and when to switch. I mean, just saying you ping every 3 seconds, 30 seconds, 60 seconds is not going to work. You have to adapt to what actually is happening on the connection. I mean, if things are varying very quickly, as observed in different RTTs, different timeouts, different loss rates for different pings, that's an indication that you should be pinging more frequently to figure out when are we stable. If some interface is expensive, you probably don't want to ping it so often. And of course, when you switch, might account into RTT, ping failure rate, whether you're paying unlimited data on your 4G or whether you have dollars per gigabyte. Lots of things you could take into considerations, but these don't have to be standardized. Next. There are some tricks learned. I mean, this technique is actually being used in Google's, what is it, third or fourth level communications tool Duo, which is kind of based on WebRTC standards, but does something else too. So one thing was exactly about the power budgets. So knowing which interfaces connect to which radios is important, because then you bunch up all the pings that use the same radio, send the pings, and then the radio can turn off again. So naturally, when you switch then when the connection starts to go bad instead of when it's gone bad, the way you do with ICE restart. But I mean, switching is still not free. So if you switch to a new network, you want to stay on that network at least until you've gathered sufficient evidence that switching was a dumb decision and want to switch back. And of course, pings aren't load. So when you switch 3 megabit video call onto a connection that had a 16 kilobit ping and handled that better, you might get congestion. So the bandwidth management needs to integrate with NICER so that you stop off, back off, and don't use that much bandwidth until you're sure you have it. Next slide. So there are open issues. The NICER works best when it has maximum information, but it has to run in the ICE controller. So it's only one of the connections ends that really does NICER. Works well for client to data center, which is not where we're using it. It works also quite well with peer-to-peer. But in order to work best with peer-to-peer, you have to exchange more information. That's where the information about network interfaces comes and the discussion about privacy. And I mean, the results have been very good. We have, when we deployed this, we see something around 1/3 of the ICE restarts simply go away. And several quality metrics are moved by significant amounts, like whole percentages. And commenting on the chat, yes, machine learning has been invoked. And it is a great way of learning from experience that your theory is flawed. So that's one of the places where the bunching of pings came from. Next slide. So I pushed this onto the IETF agenda because I think that the world would be a better place if everyone was NICER compatible. So I'm not sure where to take it. So we seek the dispatch group advice. You might say it's a bad idea, and I should never come back and talk about it again. You might say that, okay, you're doing this, don't tell anyone, or tell people. Make an IEC document or whatever, document it in public. It could be a small good idea, AD-sponsored proposed standard, or such a big good idea that there's an existing working group or a new working group that should take this on. At the moment, we're studying the options. We don't have preference. So, advice thought. This is my last slide.
Okay, thank you very much for bringing the topic. We've got 5 people in the queue. So Bernard, if you'd like to start.
Sure. Hi, Harold. I think it's a small but useful idea. We've had a couple of shots at this before. One was turn mobility, which is I've seen used for a similar purpose. Basically, you had keep a turn candidate alive and switch over, just move it to a different interface or something. That's used frequently. Another one is, I've always found it odd that when you actually nominate something, these other alternative candidates go away. Whereas before nomination, you're able to switch at any time. So I've always found that a kind of an odd, sort of a weird contradiction, that the things you describe are possible until a certain point, but then they become impossible. It's never been really clear to me why that's required. That basically you stop being able to switch at any time. So those are my comments. I mean, I think this should have been, something like this should have always been part of ICE. And I think people have been making it part of ICE for years by kind of less standardized ways of doing things. So, which don't always work. So I think of it as basically taking something that's already out there and trying to make it interoperate, specifying it somewhat better. But it's not like it doesn't exist. It's existed in various forms.
Okay, thank you, Eric Riscola.
Hi, Harold. So I guess I think I'm unable to answer this question because I'm still trying to work out what the thing that's being standardized is. I guess there's some things I think I can tell you definitely are the wrong answer, which is do not ask for an 80 sponsor proposed standard. I guess I think I can't tell with the other ones. It doesn't sound to me like it's a big idea, but I'm not quite sure yet. I guess I have some technical thoughts on it, but I think I'll spare people those in the interest of maybe trying to get some sharpness on what exactly you think needs to be documented by IETF, and then maybe we can give you a better answer where it should go.
Yeah, the slide I put up a few slides back says that keeping multiple connections open, being able to switch them at any time. And
okay, and so there'd be some extension. There'd be some extension that said do those things.
Yep.
This sounds to me like perhaps it could simply go to whoever now owns ICE, which I understand from the chat is MMusic. I guess now I will share a technical comment, which is that I think you're saying a little better than keeping all the connections open, because like they're going to be like, it's not like you necessarily want to keep the turn connection open at the same time. Like this is like kind of silly to keep that up. But presumably that's something that could be nailed down in some extension.
Actually, keeping the turn connection open might be a very good idea in some scenarios, because you might be moving out from behind your net, and or the other end might be moving out from behind the net. But what I found is that there's a lot of scenarios out there, and limiting ourselves to a specific subset is problematic. But there are some cases where it's really stupid to keep multiple connections open. Like if you have 6 IPv6 addresses connecting to 6 other IPv6 addresses, that's 36 pairs. We should only keep one of those.
Right. So it sounds like we're in agreement. There's some work to do here to specify what those things are that we could have a working group do.
Yeah.
Okay, thank you. We're just going to cut the queue here in the interest of time and just ask people in the queue to focus on maybe MMusic or other working groups, or to answer this discussion question specifically. Okay, thanks. So Jonathan Rosenberg, you're next.
Okay, can you hear me, Harold? All right, excellent. So I think it's a very interesting draft. I'm also not sure I know what answer I think is the right answer to these, but I will say it seems like you've tried hard to build something that minimizes the amount of changes required for the thing that's not the controller, but the answer is not 0. Like it does require some changes. And as soon as you do that, you have the traditional problem of a network effect protocol change where you need everyone to upgrade, or a lot of people upgrade before this becomes useful. In that regard, I sort of feel like it doesn't quite go far enough, delivering a set of tools in the toolbox that would help you deal with this problem. So the obvious gap to me seems to be there's nothing here about using multipath to actually send media on multiple different interfaces. You yourself point out in the draft that you're not sending data makes it hard to do things like bandwidth measurements or effective packet loss measurements in an effective way. So like my preference would be, I think there's a real problem here that would be great to solve. I think if I had to pick, I would prefer something that provides a richer set of tools in the toolbox so that we have one solution to this, rather than every little different bit someone needs becomes a separate standard, and then everyone implements some non-overlapping subset of those things, and we have continue the interoperable mess we have today. So so along those lines, I would sort of advocate for picking up this work in some other working group, MMusic or whatever, but I would suggest the scope of the problem be expanded to whatever is needed to better support multi-interface, multimedia communications in the use case you described.
Yeah, I have a personal opinion about multipath, which is if there's some case where it's significantly useful, I haven't seen it yet. But
really?
Usually you get much less problems by just picking apart and sticking with it. But that's something that we could debate.
Okay.
But,
Yeah, I guess that I'm not advocating that as a solution so much as that you picked like a very, like you've tried to minimize the changes on the other side. And like, it's one of these like 0-1, like as soon as you made some change, you may as well put in enough to make sure you don't need another spec in the future. And it feels like you probably could do more. That's my main comment.
Yep, and that's a very good point. And my issue with that is, of course, that it's very easy to attach the kitchen sink and the boat anchor, and then the whole thing sinks.
Yes, understood. Understood.
I just
We're gonna have folks move through the queue just a little bit quicker to make sure we get to everyone on the agenda. Thanks.
Hey, yeah, this is not a new idea, but it's good to see it again. I think it really boils down to three things that you need. Some way to basically say I participate in renomination, some way to say, hey, I'm the controller, please keep this candidate pair alive, and some way to say, hey, here's the one that I'm using right now with some sort of integer counter to say to prevent sort of out of order issues. So I think this can be added on pretty easily. I think as you indicate, Harold, like there's a lot of value in doing this. I think you probably could get a lot of the benefits of like multi-path things because the controller can try sending different paths and do that within this framework. And if it was easy to add things like, yeah, it would be nice to expand the scope maybe a little bit, but not too much to avoid the boat anchor. And I think MMusic is probably the right place to do this. So I support this work.
Thank you, Justin. Cullen, you're next in the queue.
Okay, so first of all, to avoid the pun, nice work, like it. I think MMusic is, this clearly needs a working group, okay? This is a non-trivial thing that's gonna branch into a few other things, and anytime you try and do something on ICE, it's complicated. So, I think we should proceed with this work. Yes, I think we should do it in a working group. I don't think MMusic is the right working group for this. And the reason why is just like, I don't even know why we threw ICE there to start with. That's a long historic thing, but the skills and everything else don't even really align right with the other work going on in that working group. So I think the best thing for this would be to recharter a new working group that was sort of probably responsible for ICE in general, and had this as one of the things it was going to go do. And I think that really what you're hinting at here is it's not multipath in the transport sense of multipath, but you're talking about having multiple different usable interfaces that you can move between as it becomes the right way to do them, and how to improve the user experience of that. I think that we should form a working group responsible for solving all the bits and pieces to make that happen in ICE, which this is part of the story, but not everything. So I favor creating a new working group to go do this in. That's what I think is the best way to proceed on this one.
It has some resemblance to MPLS backup paths, actually.
Maybe it might just be it's a whole new thing that's totally different that has to do purely with media. If in the WebRTC context, we have multiple media paths, and at any given one point in time, one of them is active. Maybe we have some hope of a make before break. Maybe FEC could be over one and not over the other. None of the other solutions I've seen for this really solve the make before break, which creates a hideous user experience. And we have the work you're talking about here really leads exactly to that type of solution where you could do make. You even said it, switch before it's broken, right? Switch when it's getting bad, not before it's broken. So I think you're opening up a can of worms here, which would make a better user experience than anything else we've had. Is a great chunk of work for us to take on and do. Is really close to what we already have today, so it's within striking distance of solving it. But I don't think it's just as simple as the bullet points you have in this draft. I think that these are part of the tools you need to be able to achieve that. In fact, a big part, but not the full thing. So again, I'd favor a new working group.
Okay, thank you, Cullen. Two more in the queue, Jonathan Lennox.
All right, yeah. So, I think there's some good requirements here, but also some complicated problems. Mostly about how the controlled endpoint gets to have any control, which is perhaps contradictory, which is the problem. So, and I think I think that, I originally said MMusic took ownership of ICE back, but on the discussion here, I agree MMusic is a little too much of a grab bag, and either resurrecting the ICE working group or some new name with people are coming up with various clever acronyms and clever names which they can reverse engineer acronyms for. But yeah, some working group to do various extensions and enhance the device would probably be a good idea.
Okay.
Yeah,
Thank
but
you
yeah, I
very
think possibly just resurrecting the previous nice working group. If we can find new chairs for it, is probably the easiest thing to do.
Thank you. PHP?
Yeah, I was just going to say that some of this stuff's going to be coming up at the side meeting fight tomorrow. I don't know when that is yet, but apparently an announcement should go out to the the meeting list today. I think that a working group to look at the immediate issue here is a good idea. I don't think that joining it with music is a good idea. This is something separate. But I'd also like people to think about, we should be looking at this as a research problem as well. One of the things I've been looking at is using this type of concept in combination with onion routing. And there are reasons why you might want to do that in combination with services that are out there that are not just masking traffic, that also allowing you to break down this combinatorial problem that Harold talked about. Because if you've got these 6 IP addresses that can move on one side and 6 IP addresses that can also move on another, that's a really difficult thing. If you've got information going through tunnels that are on fixed IP addresses and you're choosing the nearest one, that gives you something that's more stability. And so you're looking at these 6 things, comparing them to things that are static to the other 6 things, and it can get you around that problem, I believe. So it might be that onion routing will solve problems instead of introduce them. But anyway, as far as dispatches go, I think we need a new working group.
Okay, thank you very much. We'll have to cut it there. I think we had a lot of support for the work being done, but the question is whether it's a new working group or MMusic. So we'll revisit all of the dispatch results at the end before we go into the art area meeting. But I think we're hearing support for the work. It's just a question of where. Okay, thank you very much, Harold. And we'll move on to John to present.
Thank you. So this is a presentation of a suggestion to make SDP security description, often referred to as SDES, not recommended and historic. The draft is called SDES ... and this is a co-work between me, John Persmattsson, and Magnus Westerlund. Next slide. So it should not come as a surprise to anybody that SDES has a lot of known security weaknesses and problems. It's vulnerable to SSRC collisions, which lead to so-called two-time pads. This is strictly worse than using a 32-bit Mac, as it might lead to loss of confidentiality and integrity. There's also a lot of several described attacks in literature where an attacker can either increase the probability or make sure that it happens, depending on the architecture and deployment. Another big problem is that security description use so-called plaintext keys. So the keys often end up in log files and data retention systems, and these systems have lower security and a lot more people have access to them than, for example, lawful intercept systems. And getting access to these keys gives the opportunity to decrypt the voice calls. It's not a good idea to store your keys in a text file. Then, as explained in, for example, the paper Baiting SDES, the architecture is of splitting up the security in 2 different independent layers is flawed, or at least it's not good practice by today's standard. And this often leads or may lead to an attacker being able to get the SRTP master key on an unencrypted path. It's also known that the SDP security description is sometimes or deployed over paths where one hop or many hops or all hops don't have any encapsulating security protocol. And a big problem is that the endpoints have no way of verifying whether the path is protected or not. Next slide. And in many cases, even if there is an encapsulating security protocols, this might not have enough security by today's standard. For example, it might not use Diffie-Hellman key exchange and not offer TFS, meaning that an attacker, in case of key leakage, which can happen in a large number of different ways and has happened in a large number of different ways, an attacker can decrypt calls current, in the past, and or in the future. The situation is maybe best summarized by hacking Estes analysis, which write that the false sense of security might be more dangerous than simply leaving your voice call unencrypted. Estes gives a false sense of security, which is what NSA recently said about TLS 1.0, which is now forbidden to negotiate. New systems and recommendations like WebRTC, PERC, and BCP 8862 mandate support of DTLS, SRTP, and WebRTC for good reasons forbid any negotiation in support of Estes. The alternative and best current practice is, of course, DTLS with a good profile, meaning ephemeral, Diffie-Hellman, AAD, and so on. Then you get a good security level, you know what you get, and it provides good security against key leakage. Next slide. To summarize, SDP security description does not at all offer the security level expected by an enforced IETF proposed standard. There are also alternatives, namely DTLS SRTP. DTLS SRTP is supported by many devices, implementation, and libraries. I think the question is not if Estes should be phased out long term, but rather how. And this will take time, so we should begin as soon as possible. The current draft suggests to make Estes historic and to obsolete the RFC. Also note that Estes is not recommended, that existing deployments should mandate support of DTLS SRTP and long-term phase out Estes. Then if it's known that other endpoints support DTLS SRTP, you must not negotiate Estes or offer Estes. If it's unclear, you should offer both for a transition period. And new deployment should forbid Estes. Then the next question is, where should this then be done? Estes was standardized in MMusic, would be normal to do the work there. One reason why you might consider something else is that MMusic doesn't typically do any security, but I think this is not the security. The security weaknesses are well known. What needs to be handled here is how to handle the long-term transition to a world without Estes. That's it.
Thank you for your presentation. We've got 4 people in the queue. In the interest of brevity, please keep your answers concise. For the dispatch question, should this be handled in MMusic or somewhere else? Cullen.
Okay, so I think this needs a bunch more discussion of people that are more involved with Estes before we make that decision. I do think that it would be great to be able to have a replacement for Estes, but I don't think we have a great one right now. So can we go back to your first slide first? I'd like to go through a couple of these points. Or sorry, second slide. So this description of SSR collisions, I mean, are you aware of any widely, I mean, we describe in our RFCs how to avoid those. Are you aware of any widely deployed web conferencing systems that are vulnerable to that type of thing?
This is a summary of all the.
No, I'm asking you personally. You're one of the security experts at IETF. Are you aware of one?
Not really.
Okay, let's move on to the next bullet point.
But I haven't thought about that.
One that logs any of its keying information.
Yes, that I have heard reports of in.
Which one?
Yeah, definitely Ericsson related, but I don't remember which one and how and where.
I think, though, I agree it's a risk. So, similarly with some of these other ones, I think that though they're understood, they are worked around, and we don't have a good alternative. Go to your next slide for a second. We'll talk about the alternatives for a second. So, one of the things that when people try and do security proofs about these systems, SDES is very easy to do the security proofs with. And yes, it is like any other token that we use in a web context. You have to be careful with that token. I'm not saying it's a great design and I love it. I'm sort of saying, what are alternatives? So go to the next slide for a second. So, some of these things like the detailed SSRTP, and I'm not sure that that's a system that requires, in a web conferencing sense, that you deploy, that the cloud effectively ends up with a lot of the stuff. And it's very hard to get around that. And that's one of the things, like when you look at the phone that the president of the US uses, that the Queen of England uses, that the leader of Sweden uses, right? They're all SDES based because of the security proofs that can be done around them and alternatives. Now, I'd like to have something better, but DTLS SRTP forces us to a centralized thing where our private keys are laying around on cloud servers that allow a lot of this to happen, which is even worse. So let me just go to this other thing here. This false sense of security might be more dangerous than simply leaving your voice calls encrypted. Do you believe that?
Hey, Colin, I'm going to jump in here just a minute because I feel like this discussion would be better had with the subject matter experts and maybe in a adoption discussion like in that working group, right? Because I don't think we necessarily have all the right people in the room here. So,
okay, I think if we're going to dispatch this, we need to get to, like, there's a ton of stuff that's just wrong on these slides. It's basically,
if we dispatch this toward
conversation before we dispatch.
If we dispatch this towards music, and music would of course have to make an adoption discussion of their own. And the question is,
music isn't even a security group. That would clearly be the wrong place to dispatch.
Well, so maybe we should focus on that. Where are the correct experts gathered to have this discussion? Because I don't think they're in dispatch collectively. That's just why I'm not saying we need to adopt and work on this work, but where's the collective wisdom to make that decision?
Okay, fair. That's an interesting question, but I don't even think this is in the right place to even dispatch it, right? And I like to point out as a final thing too, that the most widely deployed alternative to this is not DTLS SRTP. It's actually MyKey. It's deployed much wider. And so the most widely deployed alternative on this is something the authors of this draft have a patent on, which isn't disclosed in any of this, right? And so there's a lot of considerations in this that I think we need to have a much broader discussion between people who actually use these systems and work with the security of this before we sort of get down to dispatching this.
Yeah. So to answer your question, yes, I think this is quite good description, as this in many cases gives a very false assumption of security. I think the security proofs of SDES is easy to make because they make assumption that doesn't not hold in reality, and these keys often. I did not see a reason to this. I thought it was we could agree that security SDES has a huge amount of security problems. I did not prepare a discussion for the security problems, but yeah.
The issue is what's the alternative that's better, right? And I think that's I'm all for us doing some work on something that works better and involve MLS keying for SRTP calls. Okay, that's what would be better. And I'd be all for doing that, but we don't have that yet. And obviously, I don't believe PERC will ever be widely deployed, so that's not an answer, right? So,
this suggests DTLS SRTP as an answer. We have not suggested MyKey in any way. I don't know why you bring that up.
Well, DTLS SRTP doesn't solve the conferencing security problem that SDES does, right? It inherently, anyway, we'll discuss that somewhere else, but thank you. I think that's key things.
Yeah. Roman, you're up. And Acker, I think you're going to have to be the end of this queue.
Okay. Hi, everybody. I think please let me know if you can hear me, but my issue is there are serious problems with what's proposed to be as alternatives, like they don't solve all the possible call scenarios. I think in general, what makes sense is to start a group which will be responsible for a replacement for SRTP, so that there is a new security protocol, be that DTLS SRTP with necessary updates or something new which actually addresses all the call scenarios for SDS SRTP before we actually deprecate that. So that's my suggestion, just to probably to have a new group which is dedicated for essentially whatever is the replacement for secure RTP protocol, which is future-proof. And once it's in place, deprecate things that we consider unsecure. And again, a lot of things that Colin brought up is consideration, and again, like it requires a lot of work before something else, before we can just essentially dismiss as the SRTP.
Bernard.
Like to speak against deprecation without an alternative, but with respect to the way this actually works, I think you really have to look at what the scenario is where SDS is used. It's obviously not used in WebRTC, but it's having worked on SIP trunking, it took an enormous amount of time before we even had secure signaling and SDS deployed. I think SIP Forum worked on this like 10 years ago, and I've only been able to get secure SIP trunks in quantity like in the last year. And for those kind of scenarios like HIPAA, actually SDS works very well, and I would argue against many of the security arguments that are described here, because all you're really trying to do is just get a hop-by-hop, security on the path. Many of the phones, for example, can upgrade to something like DTLS SRTP, going against their PBX, but the big issue is that hop up to the carrier on the SIP trunk. And I can tell you that I wouldn't be in favor of anything that a carrier is not willing to deploy, and their bar is very, very high. It's taken them enormous amounts of time just to get SDS into their SIP trunking offerings.
Okay, and finally, Eric Riscotta.
Hi, John. Thanks for bringing this up. I think this is, like, as I was saying in the chat, I think, like, it's disappointing that no one's done this before and that we were all too lazy and you were not. So thank you again. I think it's clear, like, SDS is like a nightmare. I think, you may recall Ben Wing saying that quite some time ago. So I guess I'm actually pretty surprised to hear Collins that he thinks that there are major important settings in which SDS actually solves some problem that a point-to-point thing like the DTLS SRTP does not. I certainly agree that, like, there are settings in which SRTP does not do what you'd like to do, and hence the interest in MLS SRTP and things like it. But my general impression from going through these is that SDS also does not solve those problems. It's just that they're both kind of inadequate. So it does seem. I agree that deprecation with alternatives is bad. And I certainly easily prepared to believe that there are things that for one reason or another, a point-to-point solution like DTLS SRTP does not address, and we should figure those out and figure out how to fix them, or hand wave in some other direction. I originally kind of hoped we could deal with this by just cramming this document through, which but I think that probably the situation is that there's enough installed base that we probably have to at least give people a roadmap for how to get out of the hole they're currently in, which I think you kind of indicated that earlier. So I think probably a new working group of some kind, probably is necessary, at least to do that roadmap, and that would also be an opportunity, I think, to understand Colin's objections and their validity further, and figure out which ones are important and which ones are not. I think that I didn't hear anybody speak against the idea that we should get rid of SDS expeditiously once we actually agreed that we cover all the use cases. And so I think, maybe that's like a long road and maybe it's a short road, but that would, the function of that working group would be to establish that. So I would be in favor of forming a working group with the intent of deprecating SDS. And then with any luck, it can be very quick. And with worse luck, it would be longer. But I think that, as I say, it is quite important.
Very much. So that's the end of everyone in the queue. Thanks very much for presenting, John. We'll discuss dispatch chairs and get back to you on the on the outcome here. Thank you for bringing the work here.
Thank you.
Okay, so next it's Bron presenting on the big file emailing problem.
Hello, can you hear me all right?
Yes, we can.
I have a promise to make to you. I will not ask for this to be dispatched to M-Music. Next slide, please. Cool. So here's the problem statement. End users want to send files to each other, and emails have remained limited to sizes between 10 and 50 megabytes in basically every single system. End users keep creating bigger files, and there's no standard solution for them to email those files to each other. Next slide, please. So here's some example solutions. You send an attachment via Gmail. It says, stick it in your file storage, send it, and you get something that looks pretty ugly. It's just a link to the file embedded in the email. Next slide. There's another one, iCloud, same thing. At least iCloud tells you how long the file is going to be available for, which the other systems don't. Next slide. And yet again, here's Outlook, and it does the same thing. It sends you a link to a file with an unknown lifetime. All right, next slide. So there's a few problems to solve if you wanted to be able to send large files via emails. First thing is the upload, being able to restart an upload of a large file if you lose your network connection, which still happens when you're doing really large files. I don't believe there's any standard here, but we'll talk about that later. There's also who owns or is responsible for the large file data. And finally, there's discovering that this is an attachment rather than just some inline text. So I put quite a lot of content in these slides. If we look over the next 3 slides, just leave each one up for a few seconds. Oh no, sorry, I didn't get to, I put that later. Upload a file. So that I don't know where this should go. It's a general problem for email that IMAP and SMTP doesn't support any restarting of uploads at all. For JMAP, I've got a draft for doing blob management, which in theory you could upload chunks and then concatenate them together on the server, but it's horrible. We want a more general way of doing this. I'm seeing in the chat there, yes. All right, next slide. We'll get to all this at the end. The other thing is ownership of the data. With a regular email, the entire content's sent, so you don't need to care particularly about the data once you've sent it. You can keep a copy if you want, but the recipient has the full email, they have the full context, and the lifetime is however long they keep that email for. If you send an attached link to something that's kept at your end, then there's no lifetime handling on that. There's no reference count. You don't know how long the other person's keeping their email for. And they don't have a copy of it unless they download it and then manually manage that copy themselves. All right, next. And as you can see, this is the Gmail. If you extract the URL from this, you can actually download this yourself and see me singing 4 different parts of a motet. It all combined together into a video. Yay. All right, so that's the Gmail one. You can't tell that that's without specifically Gmail scanning, you can't tell that this is an attachment rather than just a random link. That's ahref. Next one. iCloud is even bigger. And again, it's got just an href, a link in the HTML. And finally, the third slide. This is the Microsoft one, and it's got an href. All right, next. So there's 2 problems with checking the content of the links. Number one, that arbitrarily following links from emails is known to be dangerous. Sometimes get links have side effects. There's certainly privacy considerations here that you can wind up pulling content that you didn't expect. You can wind up letting the other end know that you're reading the email, unless you always check it, in which case you have the alternative problem that it looks like you're always reading the emails, and so senders will assume you're active rather than timing you out if you never look at the content. And it's very hard to know which links are attached files. So we want some kind of solution that says this is an attached file. And of course, the final problem is that the content can change after the email's been received. There's been a lot of stuff at Morg and in the spam scanning community around the idea that you show some safe content just after you send the email, which means the virus checker will receive it and check straight away, and then later you change the content that's there. So when the user goes to get it, they get the bad content. Next slide. So I would propose that the upload work definitely happens in one of the HTTP groups, because everything's moving towards that. For ownership discovery, I think a new MIME type, which we can see in the discussion in the chat, message external content already exists, which I wasn't aware of when I wrote these slides up, because this all came together just in the last few days. But discussing what to do there is going to be a question where it happens. Definitely digests for content integrity protection. Definitely an explicit expiry time. I commit to hold onto this data until such and such time. Content ID that allows you to link the content from within the message as you would with a regular attachment, and an expectation that the recipient server keeps a copy, asset virus checks it, and then retains it for the lifetime of that email so that it stays together and you have your immutable message. Next slide. I slapped together an example kind of thing, but obviously this is very much open for change. And then the final slide is the discussion points. Has this already been solved somewhere that I don't know where it is? Do we agree that this is something that needs to be done? And if so, who wants to get involved? So let's open up for chat.
Thank you. Yeah, we're going to be quite tight on timings here, so please keep your points brief. PHB, you're first.
This is actually something I've been working on, and I don't think you can do it for SMTP. I really don't. And the reason for that is that senders in SMTP are not authenticated. And if you put this out in an enterprise situation, well, people are going to be sending phishing emails, malware, ransomware, and so on in these large blobs. Now, one of the things that is happening in that iCloud workflow is that iCloud or Dropbox or Google Drive or whoever are actually providing a role as a trusted third party, and it's hidden.
I don't understand what the difference is between attaching the blob and attaching something that has some kind of digest that authenticates the content as being what was uploaded.
Well, the problem is you don't know who actually originated the content.
That's the same as an attachment that's just a blob attached to the message.
Oh yeah, but if you're sending...
it's got the same security context as a blob that's attached to the message.
Oh no, there's a difference. If I send you an attachment, that will go through the SMTP server and will go through the spam filtering and malware filtering at your company. If I send you a link,
I would expect you to do the same thing on the because it's got a digest.
No, listen. If I send you a link, the malware vector checker will pull it down and scan it, and then the second time that link is pulled down by the end user, it will be different content. The attacker.
No, that's what the digest is. That's what the digest is for.
Gentlemen, are we having the working?
But anyway, let's move on to the dispatching.
Philip, do you have a thought on the dispatch, or should we?
Well, I think it's going to be a working group if it's going to happen.
Okay, thank you.
Michael Richardson, you're next.
So I would agree with Phil. If it's going to happen, it's going to be a working group. I would say that one of the biggest problems that we've had in the history of this is figuring out who's going to pay and who's incentivized to actually deploy that. And I think that's why most of the previous systems have not worked, going back to why we had FTP by email. And I think that there's actually three steps, and I think that it's important to talk about all three steps. There's upload, there's transfer, and there's download. And in particular, one of the virtues of email is its offline nature of it. And one of the things I don't want to wait when I send you that 3 GB file of you singing is I don't really want to wait for that to happen before I go on. So a lot of that has to happen, and I may not even afford to be able to do it in the place that I'm in at that moment. So, and when you receive it, you may not want to afford to download that at that time, but you may still want it to happen overnight. I don't know, whatever. So there's a whole process there. And I think the other part of that asynchronous nature is that the network between my server and your server might not be very fast. We really should be talking about this is a delay tolerant network kind of problem. And that's where I think we should be addressing it. How do I send big things without waiting for them? And working group.
Agree, and certainly the interesting part is who is responsible for keeping a copy of the data.
Okay, John Levine, with a focus on the dispatch question, which is not dispatching, but just what do you think would be a sensible route for the work?
Can't hear you, John. No.
We still can't hear you. Perhaps we'll just ask Neil Jenkins to speak while you're sorting out your audio, John.
To say this is clearly something people want to do with email, whether or not that's, other people think that's what they should be doing, and they're already doing this, and that's why lots of services are trying to offer support for this, and so a standardized version is worthwhile.
Okay, thank you. And John, we still can't hear you. Sorry, John, we can't get your audio, I'm afraid. If you want to write what you're going to say. Thank you, Bron, for bringing the problem to the group. So we're just going to do a recap of the dispatch outcomes for this session before we move into the art area of the meeting. So to start with, all these outcomes are preliminary. It's quite hard, as you might imagine, to take the mood of a room when we are virtual, but we're doing our best. And so all of these outcomes will go to the lists to be confirmed. So for the first item on JWS CT, the dispatch outcome, we didn't hear support for the IETF taking on the work at this time. So dispatch will not recommend doing so. If the authors want to pursue ISE or otherwise, they're of course free to do that. For WebP, the dispatch outcome, we've got Murray deciding between expert review and AD sponsorship, and he'll confirm that on the list as well. For NICER, the dispatch outcome was either a new working group or M-Music to be decided by ADs and then reported to the list as well. And then for SDP, we had support for the work, just not consensus really on how to do it. So suggestions ranged from M-Music to a new working group to it's not ready yet to someone suggesting a BOF as well in the charter, in the chat. So possibly a charter to discuss further. Cullen, you've joined the queue.
Sorry, just a clarifying question about that. When you say support for the work that was presented was deprecating SDES. So you mean the work of developing a replacement for SDES, which I'm all in favor of, and if we're forming a working group for deprecating SDES, then I think that's like crazy land. So I'm trying to clarify which it is.
Yeah, Colin, so we haven't had a chance to write it up and edit it. So I think you're correct. That's just part of what there wasn't consensus on, was that whole direction. But I think we will note in the write-up that there wasn't consensus on whether doing a replacement, or sorry, whether doing a deprecation without a replacement was reached. So.
Okay, thanks.
Great. Okay, so we move into the art area of the meeting now. First up, it's Michael Richardson, just very quickly presenting on Seller.
Very quick, next slide, please. Spencer is going to do this originally, and I'm the co-chair. So this is just to let people know what's happening, sort of what's going on. Atrosky and EBML, they go back to 2002. There's a lot of running code. If you're familiar with WebM, then that is essentially kind of fork. It's a container for multimedia. It's widely supported, has a lot of open source, but it has some issues and needed some rough consensus. Next slide. And so a working group was formed in 2015. We published a first RFC. We're likely to revise it. And we have a second one, which is for the codec FFV1. And it's last, you might see it this week as 9043. And there's an FFV1 version 4 that's being worked on. And then the container format, which is implemented in terms of EBML, which is extended binary markup language. We would have done it in CBOR, but it wasn't, CBOR didn't exist yet. It will probably be finished in 2021. We don't tend to have meetings in person ever. The fourth Tuesday of the month is our virtual interim, except in July when it's almost always opposite IETF. So our next meeting is the end of August. And it's mostly open source authors, mostly working after hours. But also includes archivists for whom this is part of their day job. Next slide, please. What next? Well, so FFV1, this is why we're coming to talk to you and let you know this is happening, because we'd like to kind of hear from you as to what's more important than other things. People have a number of ideas that they want to implement, and but not always things that they know is what's going on. So there's a bunch of things that I put on the slide here about the different types of things. But for example, one of the things that you might not think of as video, but obviously it is radar or infrared images. Someone said height and age and temperature, and I don't really understand that, so I'm not going to explain that to you, but apparently that is also a thing. You could be measuring charge or elasticity or some other kind of thing in some three-dimensional process. Height is, I think, mountains and other stuff and stuff like that, and I can't explain age. And then people have talked about attestation. This format should perhaps include some kind of statement or record or signature from the device making the recording. And this might be very important. For instance, an autonomous vehicle that needs to submit its records after an incident. I think the courts would like to know there was no tampering with, and that they're getting the real raw data in whatever format it needs to be. And so I kind of invite you to a working group if you have any interests in that, or if you have colleagues that may be working in things like this, please spread the word. Thanks. I think that's the last slide.
It is. Thank you very much for running through that, Michael. Okay. Seeing no one in the queue, we'll just move to our next presentation. Brian.
Yeah. Can you hear me?
Yes, yeah, we can hear you.
Okay, thanks. You seem to have jumped into the middle there. Could you get back to the beginning? Wonderful. Next slide, please. Can you go to the next second one? There. So we did discuss this before, back in the IETF 85, and we produced an RFC for representing IPv6 zone identifiers in URIs. Why are we here today? Next, please. So the motivation is that literal addresses in URIs are mainly intended for diagnostic type use. And sometimes that needs to be an IPv6 link local address, and you need to specify the interface on the host on which that link local address is used. And sometimes a web browser is the best tool for that. And a use case that was mentioned quite recently is that this may be the only way of reconfiguring a misconfigured device that comes into a repair shop, because the only way you can get into it is from the literal IP address on a specific interface of the computer that's doing the reconfiguration. So there are real use cases for this, which are not for the general purpose user, but are for specialists. And there's at least one application that uses link local addresses on HTTP commands, and that's the CUPS printing application, which isn't an IETF standards, but it is out in the real world. So next, please. There is a syntax for that, which was described back in ancient history by RFC 4007, where you put the linked local address, FE080, ABCD, percent F0. Widely supported. It's mainly used in the ping command, but it is pretty often used. So we defined a mapping into the URI syntax back in IETF 85 or thereabouts. No current browsers use it. Actually, you can still find it in Internet Explorer if you look carefully. And the reason no browsers use it is the browser community decided not to use it. So there we are, completely useless RFC for doing something useful. Next slide, please. So there are problems, and here's the sort of most awkward one. It modifies the syntax for URIs to add a %25 F0, where cut and paste from ping command would be %F0. And it does that, of course, because that is the way you encode characters in a URI, and what you're encoding is a % sign, so you end up with %25, meaning %. That is not very handy because it means you have to modify the IPv6 address as you cut and paste it from a ping command into a URL. There are two arguments. One is that it's required because a % is always needed to escape a %. And there's an argument that isn't necessary because if parser rigidly follows the appropriate ABNF, you don't actually need to % encode the %. So the draft currently proposes not to change that, but that, of course, is open for discussion. The next slide, thank you, is the second problem, which we decided to fix by deleting a rather screwy requirement from the RFC. And the next slide is another problem which we've decided to fix by removing a rather screwy suggestion from the RFC. So what is the point here? The point is we've got some unused but useful syntax, and we'd like it to be used. So over in 6man, we can discuss the details of how to make it more usable. But then the final slide, please, is why we're here. We need feedback from this part of the IETF. We will, of course, need feedback from the W3C, and we'll need feedback from what working group, because if what working group doesn't take this on board, it's not going to have any effect anyway. I'm going through this pretty quickly. There's a lot more background if people are interested, but that's going to come up in 6man in a couple of days' time. So my real purpose here is to tell people that this is going on and to ask people who have expertise or an interest in this to take notice of the draft, either join the 6man discussion or send us lots of email, and we'll proceed as best we can. So that's it. Unless Bob Hinton wants to add something.
Did just fine, Brian. Thank you. And 6man is the first session tomorrow.
Thank you. I can see Larry Macinto, you're in the queue.
Hi. I raised on dispatch the question about at what point do we take on resolving the difference between RFC 3986, 3987, and the What Working Group Living Standard, and which proposes some extensions. And the answer I got was not yet, but maybe soon. That's how I interpreted the response. But I think if the problem is the implementation doesn't match your suggestions, then working with and you want it to work in browsers in particular, then I'd start there.
Sorry, start where?
What working group?
Oh yeah, there's an issue. There's an issue open on their issue tracker anyway. So we'll certainly do that. But
I was encouraged that someone has developed a more IETF acceptable grammatical specification of URLs that was compatible with the what working group style of a parsing algorithm expressed in pseudocode, and so that may be a good element to bridge the gap between RFC 3987, 3987, and the working group style.
Thank you both for the discussion. It sounds like Six-Man and Brian and Bob are the ways to follow up if you're interested in this work. Thank you all. We have one left, right? Rush.
Hey everyone, can you hear me?
Yes, we can hear you.
Awesome, thank you. Hey, my name is Kirill Pugin, and this presentation is about streaming protocol and the draft that we recently published a few weeks ago. Next slide, please. So first, let's talk about the motivation. So there are multiple applications that have different latency requirements in live video streaming world. So for example, live streaming of soccer match, users may be okay with 10-30 seconds latency. However, streaming gaming or other interactive type of videos would really benefit from low latency. Something like 5-second latency, probably even that is high. So the other motivation is extensibility. So new audio video codecs support. So we have few audio and video codecs coming up in recent years. New client-server interactions, multi-track support, including captions, is also one of the desired features. Next slide, please. The other really important aspect is reliability. So live streaming, at least in our case, happens a lot on mobile devices, so it's very variable network conditions. However, there are cases where servers needs to be able to also disconnect and do it in a graceful manner. The last but not the least is quality. So having a better signals from network transport to be able to adjust audio and video bitrate and to match network conditions is really important. Next slide, please. So there are obviously a number of existing protocols that could be considered, RTC, RTMP, or any sort of like Dash-like or really like HTTP-based protocols. So the RTC, for example, is mostly focused on video calling experience, and so the latency is paramount there. Whereas in our applications, we would really like to have an ability to choose one or another and have a sort of slider-like experience. RTMP, its errors to me is a little bit dead in the sense that it's old and there's no new codec support. Some implementations don't support reconnecting. Dash doesn't really allow per frame level control, and so it's hard to control latency. Next slide, please. Yeah, by the way, the other like it's not a problem with RTC, but it's a complex protocol, and so we were aiming for something really simple. So Rush is a bidirectional application level protocol designed for live video digestion that runs on top of Quick. So it's built as a replacement for RTMP that we used before, with the goal to provide support of new video codecs, extensibility, and multi-track support. In addition, the protocol is also provides an application option to control data delivery guarantees by utilizing quick streams. Next slide, please. So at the core, the client and server exchange information using frames, or you can call them messages, doesn't matter. Frames can be different types, and data passed within the frames depend on the type. Each frame has a generic header format. Next slide, please. So like length, ID. Length is tells how like the size of the data within a frame. ID is a sequence number. So every frame must have a sequence number that is greater than of the previous frame within the same track, and the type to identify type of frames. Next slide, please. The protocol itself defines say frame 7 frame types: connect frame, connect acknowledgement frame, end of video frame, error, audio video, and go away frame. Next slide, please. There are 2 modes defined. So Rush has actually defined 2 modes: normal and multi-stream mode. In normal mode, Rush uses bidirectional quick stream to send and receive data. Using one stream guarantees reliable in-order delivery for applications, and so they can rely on transport to retransmit lost data. The performance characteristics is, and the behavior is very similar to just regular using regular TCP transport. Next slide, please. So in normal mode, client sends a connect frame on assuming there is a quick connection, sends a connect frame on bidirectional stream, and then starts sending audio and video data. Only one video can be sent on the same connection. Server, upon receiving the connect frame, send the connect acknowledgement frame on the same quick stream. Because frames arrive in order, so server doesn't need to worry about it. When client needs to indicate that it's done streaming the data, it sends end of video frame to indicate that it's done and close the quick connection. Next slide, please. In normal mode, what might happen is that one of the frames, like packets belonging to one of the frames, can be lost, and all frames sent after it will not be available to the server until that frame is retransmitted. So this kind of variation of head-of-line blocking and can affect latency and introduce jitter. Next slide, please. So this what multi-stream mode is aimed to solve. So it addresses head-of-line blocking and also gives more control to application over delivery guarantees. In multi-stream mode, every new frame is sent on new quick bidirectional stream. Since quick streams are independent from each other, this allows server to receive data as it arrives and not to wait for a transmission of lost packet that belongs to other frames. Next slide, please. In this mode, frames arrive out of order. Server uses frame ID within track to detect missing frames, and it's up to the server to restore an order using frame IDs. Client can stop retransmissions by resetting the corresponding quick stream. So it can set up timer or other ways, or just basically try to send data and then reset the stream immediately. Next slide, please. So there is another aspect of reliability, as I talked about, is being able to reconnect. There are 2 ways to 2 types of reconnect. One is initiated by client, and the other one initiated by server. When client wants to reconnect, could be for different reasons, either just connection lost, or client wants to switch from Wi-Fi to cell, and so on. So client just opens up a new quick connection, close the current one, and initiate the normal connect flow, and continue sending the data on a new connection. Next slide, please. So in server-initiated scenario, server sends a go-away method. Client may send frames, continue sending frames on the current connection. That's usually required to just drain the current GOP interval. The client then establishes a new connection and continue with a normal flow. It's important to know the server may close the connection after sending go-away frames, but before the client finishes sending frames on the current connection, so this may result in data loss. Next slide, please. So that's a very rough, high-level overview of the draft, and I'm open to questions. And by the way, yeah, there is a side meeting scheduled on Friday if anyone interested in joining. Thank you.
Okay, folks, we're going to cut the queue there because we only have a minute left. So comments, but keep it brief, please. Larry, you're first.
Maybe Julius, if Larry isn't with us right now.
You're very quiet.
Okay, I'm sorry I haven't used this laptop in a while. Is it better now?
Yes.
Yes.
Okay, so everything is going out on the same 5 tuple, right? And everything is encrypted.
Correct. Yes,
So if a
that's-
router wants to apply different drop priorities to audio and video, that's a problem that also exists in WebRTC if you use bundle. If a router wants to treat differently the audio and the video flows, there's nothing it can do. Is there?
So it's up to application, right? So it's not.
No, I'm speaking about the router unknown to the application. Are you counting on the IPv6 flow ID to do that? Or how can a router distinguish the different flows?
So it doesn't.
Okay. Okay, so that might be a problem.
I think if we can encourage you to take the conversation to the side meeting, and sorry, Bernard,
Sure.
we're just going to, because we're finishing now, so we'll just run through the last couple of slides. Thank you, Carol, for coming and for presenting your work. Do go to the video and just over quick side meeting for more discussion. This is just an FYI. And hopefully Meet Echo is just hiding the arrow that I need to advance the slides, which is, there we go. So yeah, just a note that there are some BOFs coming up this week that you may be interested in. The first one is tomorrow. Danish is having another BOF, and Oblivious HTTP or OHTTP. The Medina's work on Wednesday, SINS on Thursday, APN on Friday. There's a new art working group tomorrow as well. All of these times are UTC, but that's sedate, which was a result of a dispatch item at the last meeting. And then just other interesting meetings. SEC dispatch is earlier than usual, so it's normally I think on a Thursday, but this IETF meeting is today. So do not miss that if that's one of your dispatches on your agenda. There's also Gen Dispatch, SHMU, RFC, Editor Future Development Program, and finally the IAB open meeting as well. Patrick, anything to kind of add?
We had a really full agenda and 91 slides, and I really appreciate the dedication people gave to addressing the dispatch questions in particular. But that's great. Hopefully we'll all be together in a meeting or two. I think this is a forum that's definitely easier to do in person, but I really appreciate people sticking with it.
That's great. Then, yeah, that's the end of dispatch for IETF 111. We'll share all the results to the list and the minutes as well. Okay, thanks everyone. Have a great IETF week.